So notice you have log base b of two things being multiplied. You can expand that by taking the log of each one of them and adding them. Law 2, you take the log base b of two things being divided. You can separate them and expand them by subtracting. And then law 4 is probably the most difficult one to kind of see expanded or condensed. Whenever you have an argument with an exponent, that's considered the condensed version. When you bring that exponent out and multiply it by the log, that would be the completely expanded version. So it's just the left side is the condensed version, the right side is the expanded, because we're going to do both of those things along with evaluating, simplifying, combining, and expand. All of those things today with those laws. Now, these first ones, as with all of these, depending on what you see when you work the problem depends on if you want to use a property, a law, the definition of a logarithm. Sometimes there's multiple ways to do it. Sometimes it looks like there's multiple ways to do it, but then you have to go back and use a different method in order to get to the answer. So this one says evaluate, so we're going to have a value. So what we've been doing before, we could say 4 to the what equals 2, 4 to the what equals 32. We could do those separate, find those values, and add them together. Or we can use that law number 1 from today, where because we're adding, we can combine those together and say log base 4 of 2 times 32 to have log base 4 of 64, and then we can use that definition, 4 to the what equals 64, and we get 3. So that's using the law from today. Not the only way to do that problem, but one way to do that problem. Letter B, we could do that both ways also, but when we get to a certain point, 2 to the what equals 80 and 2 to the what equals 5, that's not something we can figure out. So we couldn't use a previous method with letter B because of the numbers involved. It all depends on what numbers are involved. Letter B, we have to use the law. It's number 2. Log base 2, if we're subtracting, it becomes 80 divided by 5. Log base 2, 80 divided by 5 is 16. So now we say 2 to the what equals 16, and you get 4. We have seen this one a couple times. I know I've done this one at least 3 times in the last couple days, 4 to the what, log base 4 of 64. Some of these you're going to recognize, and they're going to happen over and over again. It's not on accident. It's not like, oh, she put it on there again and we already had that one. There's just so many numbers we can give you without a calculator. We're not going to give you just ginormous numbers. So there is a limit to the numbers that we can use that are perfect squareds, cubes, fourths, and fifths. All right, letter C, same thing. We could change that one. We could change the base of 16 and make 16 2 to the 4th to the 3rd and use a property from 10.1 or 11.1. We can use this 4th law right here and expand it. Hey, I'm going to use that one since that's what we're doing today. So I'm going to bring this 3 out in front and make that 3 log base 2 of 16. Now I have to find what is log base 2 of 16. Log base 2 of 16, we just did that, is equal to 4. So we have 3 times 4, and you get 12. Not the only way to go about doing that problem. That is just one way. If you do it a little bit different and get the same answer, that is fine. A different way and a different answer, not fine. All right, so that's evaluate. Now we're going to expand. So when you expand, it means you are completely expanded. There are no parentheses. You're not unexpanding by factoring. There's nothing like that. No parentheses, no exponents. Each argument is completely by itself. Okay, so if you're expanding, each argument is completely by itself. That's one of the key things to recognize. So all this one is log base b of mn, two things being multiplied. So this one becomes log base 2 of 6 plus log base 2 of x. Each argument is completely by itself, and so that is expanded. There's no exponents, there's no parentheses. It's completely expanded. Letter B, same thing, but then there's also law number 4 involved in that one. So if you can do two things at once, that's fine. I'm going to do one thing at a time. So I'm going to first change this to log base 5 of x cubed plus log base 5 of y to the 6th. If you can do everything at the same time, that's fine. I'm just going to show a couple steps for those people that can't see all of that going on at the same time. Now, the argument is not by itself. There's an exponent here, there's an exponent here, so we have one more step. That would be bring the exponent out. So 3 log base 5 of x plus 6 log base 5 of y. Now, the argument is all by itself. So now that is a completely expanded problem. We are not going to factor. If you factor, then it's not completely expanded. Okay, now you're combining things again. So no parentheses and the argument all by itself. The natural log is exactly the same thing as log. All natural log is a log with a base of e. We just have a special way of writing that using natural log. So all of these laws of logarithms is the same thing as natural log because all the natural log is a log with a base of e. So we're going to use the same properties. So this property is natural log of m divided by n. So it becomes the natural log of x minus the natural log of y to the 1/2. This one's fine because it's by itself, but this argument is not by itself. So we have one more step to bring that 1/2 out in front. Now the argument is by itself. There's no parentheses. It is completely expanded. And this last expand problem. How you do this, the order that you do it in is kind of up to you. There's different ways to go about doing this. We can take care of that squared first. We can square all those terms. But it doesn't matter. What I would do first is kind of distribute that squared to all the terms in the parentheses, because what I see happen a lot is if you do the squared first to the outside, you forget about the parentheses, and maybe you write the parentheses the first step, and then they eventually start to go away. So I'm going to first make this log of x squared, y squared, w squared, z squared. You could just make it 2 log x, y, w, z. But then you have to remember that 2 goes to the whole thing, not just the first one. And now I'm going to take care of that division. So I'm going to make this log x squared, y squared, minus log w squared, z squared. If you can do more than one or two things at a time, that's fine. I'm doing one or two things at a time so you can follow me if these are a little bit more difficult for you. All right, so now I'm going to turn these one term into 2. I'm going to turn this single term into 2. Because there's a minus, I'm going to have to use parentheses. So this is going to become log x squared plus log y squared minus, I have to use parentheses here, log w squared plus log z squared. I have to use those parentheses because I'm turning a single term into 2 terms, and there's a minus out in front. One term into 2, the whole thing is minus. The log w squared is not the only thing that's minus. Everything here is minus. So now I'm going to do a lot of things all at the same time. So log x squared. This still isn't completely expanded. 2 log x plus 2 log y. I'm going to distribute and bring the squared down at the same time using just distributing and that law number 4. So minus 2 log w minus 2 log z. There's no parentheses. Each of the arguments are all by themselves. So I'm done. Do not divide by 2. You can't just randomly divide a number by 2. If the answer is 10, you can't say I want to divide that by 2. So same thing here. You can't just randomly divide an expression by something. If we were doing something else, we could factor, but that's not what we're doing here. We're expanding completely. So no parentheses and the argument all by itself. All right, now the opposite, we're going to combine. And with combine, you always try to get it down to the smallest possible thing. So if you can get down to a single number, fine. If you can't, then you just leave it as it is. So if you can evaluate at the end when you're combining, you get it down as far as you can go. The only way you can combine is if these bases are the same. If the bases are not the same, then you're just done. You leave it where it's at. So since those bases are the same, we can say log base 5 of 2 times 3. So that's log base 5 of 6. 5 to the nothing equals 6, so we're done. We can't go any further than that. If that was log base 6 of 6, we could go one more step and say that's equal to 1. Or log base 36 of 6, we could do something with that. But log base 5 of 6, 5 and 6, there's no way to get those to be like bases, so we stop. Now letter B, some of you can look at that and know the answer immediately. If not, I'm going to do just, all I can do is add 2 things at a time. So I'm going to add these 2 first. So that becomes log of 18 minus log of 2. Then log of 18 minus log of 2 is log of 18 over 2, which is log of 9. The base is 10. 10 and 9 can't be written with like bases, so we're done. All right, 1/3 log 64, 2 log 5. So log 64 to the 1/3 plus log 5 squared. We can do both of those. We can evaluate 64 to the 1/3. 1/2 is the square root. Raised to the 1/3 is the cube root. Raised to the 1/4 is the 4th root. The 1/5 is the 5th root, and so forth. So log of 64 to the 1/3 is log of 4 plus log of 5 squared is 25. Now we use that law number 1. 4 times 25 is 100. We do know what the log of 100 is. It is 2. 10 to the what equals 100? Or we just remember log of 10 is 1, 100 is 2, 1,000 because there's 3 zeros is 3, and so forth. Letter D is one of those you can kind of decide to do what's in the parentheses first, or you can distribute and then do that. I'm going to do what's in the parentheses first and then deal with the 1/2 at the end. So 1/2, I'm going to combine those 2 first. So log base B of mn minus log base B of p. Now I can combine those 2, so I have 1/2 log base B of mn over p. And then that 1/2 goes to the argument, looking back at that law number 4. So it's log base B of mn over p to the 1/2. Now, on a problem like this, it doesn't tell us exponential or radical. If the directions tell you something about exponential or radical, you have to be sure and leave it in that form. If it doesn't specify exponential or radical, if you don't like the exponential and you think this makes more sense, log base B, you can say the square root of mn over p. You can do that. Either one of those is okay. Or m to the 1/2, n to the 1/2, p to the 1/2. That works also. Any of those are okay as far as when you are combining them. If you're going to write it with the square root, just be sure that your square root goes over the whole fraction and not just the numerator. If it goes over just the numerator, that's different than the numerator and the denominator. If you mean it to go over both, you need to write what you mean. But either one of those is completely combined. All you can do on that. All right, and then the last thing, the change of base formula. So this would be with your calculator. The quiz tomorrow will not have any calculator on it. This will be stuff we use more with the application problems, but just learning how to use it. Or your quiz on Thursday. Your quiz Thursday will be all non-calculators, so you don't have to worry about your calculator on Thursday. So this change of base formula, couple things. A long time ago, you didn't have a calculator that could actually make the log look like this. So you had to use this change of base. But in calculus, there are times where you have to use the change of base formula where this little thing will not work. Okay, so just be sure you know the change of base formula. But as far as doing this on a test or quiz in here, either way will work. You get the same answer no matter which way you do it. But depending on what calculator you have, it's going to depend on which one you can use. If you have an older calculator that doesn't have the F1, F2 buttons, or even if you have those F1, F2, F3 buttons, some of your calculators aren't updated and it doesn't let you do that. So again, it just depends. If you borrow someone's calculator on a test or quiz and they don't have the calculator that you use, okay, that's something that you have to figure out as well. Okay, I'm not going to remind you what it is because you have somebody else's calculator. So again, be sure that you know how to put this in. If you always have your calculator, terrific. If you tend to not have it, you got to be sure you know how to do these. All right, so if you hit the alpha key, which is the green key, and hit F2, so the window right here, you get this, whatever that is right there. Okay, you get those 5 things that pop up. Some of you use that all the time. Okay, if you use it all the time, you know it's there. Maybe even used it last year. So green button, window, and then if you hit number 5 or go down to number 5, log base is what it says. And then if you hit number 5, your calculator pops up like this. It gives you a place to put the base, and it gives you a place to put the argument. So you can put those in. If not, you can use the change of base formula, and you get the answer just the same way. All right, so when you plug that in, obviously there's the first answer, 0.77, and since we're rounding to the thousandth, that would be 4. So 0.774. That next one, log base 9 of 20, however you do that, log of 20 over log of 9, or use your change of base on the calculator, you should get 1.363. And then log base 3 and 16, you get 2.524. All right, so that is change of base.